Hello children, let's start with some new topics of laws of motion, and the name of the topics are Newton's third law and conservation of linear momentum. Class 11th. The objectives of today's topic are state and discuss Newton's third law. State and explain law of conservation of linear momentum. Let's start with Newton's third law. According to Newton's third law, to every action there is an equal and opposite reaction. Suppose a body 1 exerts a force on a body 2. This force is called the action force F12. Now the body 2 exerts an equal but opposite force on body 1. This force is called the reaction force F21. By Newton's third law, F12 is equal to F21. The negative sign shows that the force of action and reaction are acting opposite to each other. The characteristics of Newton's third law are: action and reaction forces occur only in pairs. These two forces act on different bodies. And the third one is action and reaction forces are always equal and opposite. Some examples of Newton's third law are pushing a wall, second, rowing a boat with an oar. Let's understand Newton's third law using some examples. Hitting a nail using a hammer. When we hit a nail using a hammer, the force exerted by the hammer on the nail acting as action force is equal and opposite to the force exerted by the nail on the hammer, which is reaction force. Let's take another example. When we step forward from rest, our foot pushes backward on the earth. This is an action force. The earth exerts an equal and opposite force called reaction force, which help us to move forward. This causes a forward motion. Let's take third example. While swimming, the man pushes the water backward. This acts as an action force, and in return, he is pushed forward due to the reaction of water, which acts as reaction force. So children, I hope you have understood the applications of Newton's third law. Let's start with law of conservation of linear momentum. When two or more bodies interact with one another, their total linear momentum remains constant, provided no external force is acting on them. Let's start with the derivation. Consider m1, m2 as masses of two bodies A and B moving in the same direction along a straight line. Let their velocities be u1 and u2 respectively. They collide and they are in contact for a small interval of time delta t. Their velocities change to v1 and v2 respectively. Suppose a body 1 exerts a force on a body 2. This force is called the action force F12. Now the body 2 exerts an equal but opposite force on body 1. This force is called the reaction force F21. By Newton's third law, F12 is equal to F21. Students, momentum of mass m1 before collision will be m1u1 and momentum of mass m1 after collision will be m1v1. Momentum of mass m2 before collision will be m2u2 and after collision will be m2v2. As we have done the definition of impulse, So we will be using here this definition of impulse, which is related with change in momentum. That is, F12 delta t is equal to m1 v1 minus m1 u1. Similarly, this change in momentum of mass m2 is given by F21 delta t equal to m2 v2 minus m2 u2. Let's add equation number 1 and equation 2. Children, on adding, we will get the result m1 v1 plus m2 v2 minus m1 u1 minus m2 u2. Now students, as we have done already in Newton's third law, the action and reaction forces are equal and opposite. Therefore, F12 plus F21 is equal to 0. The result comes out to be M1 V1 plus M2 V2 is equal to M1 U1 plus M2 U2. That is, momentum after collision is equal to momentum before collision. In this way, we can say the momentum of an isolated system is conserved. Students, in this way, we can derive the law of conservation of linear momentum using Newton's third law. I hope you have understood this derivation. Now let's study some applications of conservation of linear momentum. The first application is explosion of bomb. When a bomb explodes, the different pieces of the bomb move in different directions with different velocities, so that their total momentum after collision remains the same as that before collision. So here, law of conservation of linear momentum is applied. Let's come to another example, collision of balls. Children, here in this picture you can see a number of balls being suspended. When only one ball is made to strike from the left, one ball at the opposite end moves away. But if two balls are made to hit the row of the remaining balls, two move away from the other end, so that the total momentum remains conserved. So children, I hope you have got an idea about conservation of linear momentum. Thank you students for watching this video.